So once again, this is MathML and LaTeX Workflow 2017, always a work in progress. My name's Elizabeth Pyatt. I do STEM accessibility, meaning I help make sure content with equations is accessible for people on a screen reader. But some of the techniques we're talking about will help other people as well. If you want to contact me, you can try either accessibility web or accessibility at psu.edu. That goes to a listserv, which I'm on, and other people are on as well, and either will work. So what's new for this year? We'll cover everything, but I'm going to be looking more at WIRIS, which is an online math editor, as well as MathType, which is an application. We'll definitely talk about Canvas. It's gotten better. Our recommendations are better than they were the last time we talked, but there's still a few gotchas I want to talk about. And then we're going to talk about MathML, MathJax, which helps MathML work across browsers, and how this all works, not just in Canvas, but in sites and just in web pages in general. So the first piece of the puzzle is the equation editor. So everything starts there, and there's some good ones that are very helpful. And just sort of, I think when you're faced with dealing with math, you don't have to understand all the symbols to use them. You just sort of have to know where they go in the equation. If you're really interested, Wikipedia will explain symbols for you, but that doesn't mean it's going to make sense. I know I've tried it a few times, but also just they're not just random symbols. They can mean light, or in this case, in this 3D print, they can mean a bunch of concentric circles with a peak in the center. So there is meaning in math if you want to look for it, and I find it beautiful myself, but I know not everyone does. This is MathType. This is an application that has a version for Windows and a version for Word. And on the Windows version, there's also a plugin for Microsoft Office for Windows that can be very helpful. Basically, the idea is you have these palettes and symbols. So this is a tool to let you insert things in different locations. So you might have parentheses, so different types of parentheses, and the square box means put something here. Square root, fractions. This area has superscript and subscript, or both in this case. If you're in statistics, you may see a lot of the summation formula. And in fact, there's a statistics pad that has some of these you can ready to go for you. In MathType, you can build your custom templates. So if you're working on a course with a lot of the similar sets of equations, you can program some templates for that. But today, actually, I'm going to demo. There's one called WIRIS, which Catherine Murphy pointed this out to me. And it actually does very much the same thing. Excuse me. It's a little, I think the interface is a little simpler, but you have to remember to save your output because it is in the cloud. So get here. And so what I'm going to do is do a demo. So I'll start out with E equals MC squared, but if you can remember algebra, you can move things around and get different variations that say the same, well, mean the same thing, but they're focusing on different elements. So E, I'm going to start out with E, and then you type E equals so far so good, and then even MC. And now you have a superscript 2 to worry about. This little template here, you see this is the superscript template. There's a subscript template here. So I put that in. That's E equals MC squared. I'm going to do another one. So this time I'm moving things around, so I'm solving for m, as they say, and hopefully I got this right, but m equals, and now you're going to have a fraction. So I usually work from the outside in. So I have a fraction, e's on the top. In this case, I can copy and paste. But if I didn't have to do that, I would just put in c, and again, my superscript. And this is sort of how you start working and building different elements. The last one I'm going to do is c equals the square root. So c squared would be e over m, but I just want c, so I take e over m, and it's the square root of all that. So I have a square root, and I have a fraction under that. And ta-da! Got some equations already. So I'm going to see if I can find the chat room. Are there any questions? I lost the chat room already. Well, I will. There we go. Okay, thanks. All right, so we're back in business. All right, I'm going to do a more complicated one. If you've had statistics, it's this one, the standard deviation standard deviation equation. And actually, the key to some of these trickier ones, if you're not used to them, again, is trying to break down. So the first thing I notice is I have this sigma, that's a Greek symbol. So I usually look for the Greek symbol palette, and I find this is the sigma sign. It helps if you know your fraternity names. This is one big square root, and there's like a fraction. So 1 over n, and then there's a big summation formula. So summation means just adding a series of things. And pretty much want the deluxe package of that if I can get it. And so there are a few limitations. I'm not sure how to get everything. Let's try this one. That might be the one. Yeah, it's the one I want. I think some of these are variations of another. So I knew I wanted the capital sigma, and I wanted the big N, and I equals 1. All right. And all right, so I'm going to get rid of, it's a little kludgy, but I think hopefully you're getting the idea of how these things work. So we're not here to necessarily build equations, but to put them in different locations. So I'm just going to move on. So as I mentioned, there's WIRIS, which is free, and that's what I'm going to be using in today's demo, but there's also MathType, which has similar functions. What are the pluses and minuses? Well, WIRIS is free, but it's in the cloud. MathType is about $60 for the academic price, which isn't too bad, and plugs into, it's available on Windows and Mac, and if you're on Windows, will work with your Microsoft Office products pretty well. So you might have noticed I haven't talked about, well, isn't there an equation editor in Microsoft Office already? Yes, there is, but it doesn't help you at all with MathML. So you're out of luck there. So that's why I talk about these two. The third option that if you're faculty, math faculty or no math faculty, is LaTeX. I'll talk about that in a minute, but that also helps out with grading accessible math. They both do all sorts of equation types. They both can help with LaTeX MathML conversion, and because LaTeX is such a common format used in the math community, that's really important. WIRIS basically works only with MathML or LaTeX. Sometimes if you need some other type of format, you might need MathType instead. Really what you see is what you get in terms of tool sets. With MathType, you can program templates if you need to. Both of them do a little bit of chemistry, but not, so they can do things like simple chemical equations, but some complex formulas where you have polygons showing, not necessarily. I mentioned Microsoft Office. Formatting tools, so WIRIS has controls for whether you want things boldface or different colors that are easy to get to. You can do it in MathType also, but it's a little more indirect. You have to go into the preference panels. And the last one is right to left formatting. All right. So Robin, is there any way to save formulas or terms? In both of them, what I usually do is, probably the best way is I copy the MathML output and save that, or the LaTeX output. And I'll show you what that means in a second. But yes, there is a way to save it. But with WIRIS, you have to remember to save it to your own local drive. It's not like you can get an account and it'll be there for you. And all right, so that, you're right, that wasn't too bad, but the jargon is where it can get a little confusing. There's way too many math words in there. So the first one I'm going to start with is, I've already mentioned LaTeX. It's a way of formatting things for the internet. It was I believe started before we had the WYSIWYG tools that we have now, but it's still very much used. It's very popular, and it's not that hard to use if you know math. So this is E equals MC squared, MC caret 2. This is e to the 1 pi equals -1. So again, e caret. Then you have a lot of curly brackets. And then this is the sigma standard deviation equation I was trying to replicate. And so if you see a lot of curly brackets and backslashes, you're probably working with LaTeX. So this is LaTeX. This is MathML. And MathML is sort of a sister language to HTML in that they're both meant to be extended markup languages designed to work on the web. They have angle brackets. So if you've ever seen HTML tags, these look like HTML tags. And they're directly supported by screen readers. LaTeX is a little trickier. But already you can see one reason people don't just code in MathML is it's a lot more complicated. This is E equals MC squared. It took one line. E equals M caret 2, MC caret 2. This is like 10 rows or something like that. Not quite, but close enough. Fortunately, that's where your equation editor comes in. That's going to make it for you. Some other important jargon. This one, so this starts out math, open tag, end tag, math. So in between these tags means there's going to be an equation. This other report, XMLNS, means XML namespace or namespace, and there's a URL pointing to the W3C. That just means that when the browser sees it, it sees that it's a math equation coming, and it's a link pointing to the standard. in this case, MathML 2.0. Pretty much it should be in there for browsers to be happy. If it's not there, the results are a little unpredictable. So this is the namespace. And there's another version, there's MathML 1.0, which we don't use anymore. And then there's one called M namespace that was invented by Microsoft. And this was popular back in the late 90s, early 2000s. And it's just like MathML, except there's an M colon before all the tags. You're thinking, why did Microsoft do this? Well, basically, it took a while for MathML standards to be built and for browsers to properly recognize them. And in fact, right now, pretty much only Firefox and sometimes Safari recognize raw MathML. Everyone else needs help. This was designed to be used for Internet Explorer with a MathType plugin. And you may be thinking, and it doesn't even work anymore. And you may be thinking, if it doesn't work anymore, why are we still worrying about it? Well, sometimes things export. When they say they do MathML export, they might be exporting this instead. I just saw that a few weeks ago. So if you happen to see this, it's an easy fix. You just have to remove the math colon, and then you get your regular MathML again. But it does exist, so I have to point it out. So we met MathML, we've met M-space MathML as opposed to regular MathML, and now we have to meet MathJax. So MathJax is sort of the JavaScript component that makes MathML work on a lot of browsers. It's an open source math script library. It's managed by the American Mathematical Society, so there's a lot of support for it. And basically, it tells browsers, well, if you don't natively support MathML, here's what you need to do, and it will fix it for you. There's another component called MathPlayer, and it's made by the same people who make MathType. That is Design Science is the vendor. It used to be that on screen readers, you had to have MathPlayer, and it had to be in Internet Explorer in order for it to work, and you had to have the Microsoft variant. That has changed. But sometimes if you want someone to consume MathML on Windows and they're on a screen reader, they can do it, but they have to have MathPlayer 4 and use the NVDA screen reader software, which may or may not be popular. I do know that the one student I work with who uses a lot of math really just wants it in HTML, and he prefers Firefox, so we don't really bother with Word at the moment. That could change in the future, but right now that's where we are. All right. So if you have any questions, I do have the chat room open now, so please go for it. So basically, this is what a page with an accessible equation would look like. And I think I'm going to go, I think this will make more sense once we do the demo. So I'm going to actually skip to the demo as quickly as I can. Just some comments. In terms of support, Firefox has the best support. It supports raw MathML. It supports MathML with MathJax. But since not everyone is on Firefox, most people implement with MathJax, and then it works pretty much on every visual browser that I've been testing. Screen readers, JAWS 16 really improved their MathML capability, so now you can just use Firefox. Before that, you had the Internet Explorer MathPlayer combination. NVDA, that's the only one that uses MathPlayer 4. If you do use it, again, you have to use Firefox or Microsoft Word. VoiceOver on the Mac has decent support. It may be better without MathJax, and iOS Safari, which is your phone, has some support too. All right, so I'm going to go through the workflows. Like I said, I'm going to explain the HTML workflow first, just because if you're having any problems with another system, you kind of have to fall back on that to do a little bit of debugging. So accessibility.psu.edu/mathml has some good documentation on what I'm going to show you. That's where the actual codes live. Or accessibility.psu.edu/math. So again, we're going to start with the equation editor and add different components of it. So I'm going to show you what we add before I do the demo. All right. So if you're in MathType, I mentioned that you build the equation in that editor, and then you can output it as MathML, and it's not an export option, it's a cut and paste, cut and copy preference. So you go into the preferences for cut and copy and choose what you want to export at, and you have MathML with namespace. That's the one you want. You can also export pictures, and you can export LaTeX, and it's in this one. That's the TEX for LaTeX. And then you're going to create an HTML file, and that's where I think I'm going to start my demo. So I'm going to go into WIRIS. So I'm going to pretend this is an actual formula that I want to use. And so this is WIRIS.com. You want they have this MathML LaTeX converter. And so it starts out with a fraction, and it shows you what the MathML looks like versus the LaTeX. But the important thing is you can, there's my C-square again. You can start editing things. So I'm just going to build a random equation. So, because we all want to know what the fourth root of C² is, and make that into a fraction. And oh, I don't know why that popped open, but that was lovely. And so that's crazy enough, I think. So I think you get the idea. And you'll have a LaTeX, and we'll do stuff with that later. This is the MathML. And so I'm just going to open up Dreamweaver. I'm going to assume you have going to just create a blank HTML document. So this is, I'm in split view. Usually when you're working with MathML, you want to work in the code view. So you want to put stuff in the body of the text. Put the MathML here. And if you're working in Dreamweaver or a lot of other systems, it looks like gibberish. Dreamweaver does not really support MathML. So I'm going to save this to my desktop. So, like I said, this is going to open this up in Firefox. And You can see on your screen something resembling what I put in the equation editor came out. You can actually put styles in here, so I'll just do it up here actually. So I'm putting in a style sheet real quick. And if you know CSS, which is cascading style sheets, you can apply them to math tags directly. So and as you can see, actually the default size is a little large, so I actually often do that when I can. And let me see if that'll, let's try XX large. Hopefully remember. There we go. So there it is. Now I'll open this up in Google Chrome. So I'll open up. And again, it's the same problem as in Dreamweaver. It doesn't show up. So the next thing, in order to make it work in Google Chrome, I'm going to add a script. So let me see. So we've completed this step. So the next thing I need to do is add a link to MathJax to make it work in all the browsers. And I do this, there's a script tag and it goes into the header. And the one change that happened was you might see a lot of documentation pointing to mathjax.org. That is not correct. You need to make sure you're going to cloudflare.com. That's where MathJax lives right now. And I have this, I will just copy and paste it. But I have that also on the website on the MathJax page. So I'm now in the, this is the body, now I'm in the head. So I'm going to add that script link in the head. If you are working with something like Drupal or some other homegrown content or home managed content management systems, you should be able to configure your content management system to do this for you already, so that the people editing pages won't have to do that. So now once I'm back in Google Chrome, because I added this line, now this formula works again. But unfortunately, all the style commands I put in no longer work, because if you look, I'm going to see view page source, it's significantly changed. It's there, but the JavaScript is adding specific tags with styles that's overwriting your tags with styles. So there are ways around that, but we're not going to get into that right now. The important thing is it's showing up. And because if you really couldn't see it, you can zoom in, and there are little quirks in the display, but basically it remains crisp, whereas if this had been a GIF image, it would have gotten fuzzy by now. So that's the other advantage. The other reason that MathType is MathML is popular with screen readers is you can select different parts of the equation. So if you're on a screen reader and you're trying to understand all the different components, you can say, all right, I just want to see what's on the top part of the fraction versus the lower part of the fraction. This would be the numerator versus the denominator. Or I just want to see what the summation part of the formula is and reread that. So that's why MathML is so popular. So I realize I have some questions. How do you get the square root to cover the whole equation? In the math editor, you have to finagle it. That was what I was having trouble with. You have to finagle it so that the square root covers the whole fraction. If I were in linguistics, I would call it scope, but that probably doesn't mean anything. But the idea is you need to make sure that things are properly nested. And that can be a little wiggly sometimes, I will admit. I think LaTeX, one reason it's popular is that's a little easier to control. Next question, would you recommend a certain browser? So from a screen reader perspective, Firefox seems to work best. And also from a visual perspective, however, beyond that, just make sure you have an up-to-date browser would be my recommendation. I tested this with Microsoft Edge, with MathJax, it seems to be fine. Safari, Chrome. Not sure about Opera. I'm not sure Opera likes MathML too much, but the major ones should work okay. All right, so we've gotten this page I've done with gibberish.html. You could give to a student on a screen reader, and they should be able to read the browser, read the equation. So I'm going to go back to PowerPoint. Of course, how many faculty do you know who use HTML? Not that many. We need other workflows. So that's where we come into Canvas. So what happens in Canvas? I'm actually going to talk about what happens and then I'll do the demo. So Canvas basically is a LaTeX editor. So it does have a WYSIWYG equation editor. Some of you may have already noticed it doesn't have a wide range of features in it. WIRIS and MathType have way more options. So if you run out of options, what might happen is you might have someone who uses LaTeX. And fortunately, if you switch the view to advanced, this is the advanced view, you can cut and paste LaTeX code in there as opposed to MathML code. And that's what we've done here. And you can see the output here, L to the -1, blah, 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 blah. That was an equation I got for another course. So what happens though, it sort of converts it to MathML, but in a unique way, which I am going to try and explain just in case you need to debug it. So what happens is once you put in the LaTeX, Canvas will generate an image, and it will give it a special class because it's going to do weird things. So it's going to live as an image. If you know about alt tags, it gives it an alt tags, which is the description that's initially read out to the screen reader. And what it does is it takes the LaTeX as the alt tag. So if someone is on a screen reader, they're going to hear both LaTeX and MathML. And so if you, depending on the view, you might see this data-m MathML attribute, and it's going to give you MathML, where this and LT is the angle bracket. That's basically the hidden MathML it uses to present to screen readers. And if you see the published form, instead of the data MathML attribute, you might see this image and then this span class hidden readable. And then if you expand it, you'll see MathML. But actually, when that's working, that works pretty well. The good news is, so let me go into a Canvas course. So I'm going to, this is my crazy MathML and LaTeX. So in WIRIS, you have access to both at once. That's one reason it's easier to demo with WIRIS and use sometimes as well. My sandbox course. So I'll just create a new page. All right. So I'm in the WYSIWYG editor for a page, or also maybe in a quiz or discussion board. And I'm looking for the square root of x symbol. That's the math equation editor. Okay, so right now I'm in basic view. I could build the equation, but in this case, I'm going to show you how to import the LaTeX. So here's the LaTeX with this backslash fraction. I've copied it. And so I put in the LaTeX, and I know it's worked because it actually gives me what I thought I wanted to build. And it can be nice if I realize, oh, wait, I meant to make this the sum. I didn't mean to go to 3. I meant to go to 5. I can change it in here. It changes it down here. Voila, you're done. And because of this hidden MathML, as long as it's working, you've satisfied screen reader accessibility. You might need to explain to the student that they're going to hear the LaTeX, but then they'll hear the actual equation. So it's not our favorite solution, but it is working. And I'm going to publish. I'm going to save it. And if I inspect it, I'm going to get here. See, there's the class. So that's the image. There's the MathML. I think right now you're seeing MathJax. I think we're testing a MathJax implementation right now, to be honest. So you might be seeing that instead. We should have an update for you soon on the status of that, but I don't have any other information other than they're very actively working on it, and I'm crossing my fingers because that will enable some workarounds. So hopefully, that may have looked really confusing, but the short and the sweet is if you use the Canvas math editor either in WYSIWYG mode or in LaTeX mode, you have an excellent chance that you'll have an accessible equation. However, because it's such a complicated system, we have recently found, for instance, that it works on pages, it works in quiz questions, but it might not work in quiz answer responses in the feedback. Someone in World Campus found that out, and there is a ticket out. So hopefully that will get fixed soon. They probably forgot to change something in a component, but it's always something. I said this last year, and I'll say it again this year. We just recommend you use the native Canvas MathML editor whenever possible, as opposed to an image or PowerPoint. And your chances that you'll have something accessible are pretty good. If something goes wrong, if a screen reader user says, wait, I don't understand it, pass it along, obviously. But also there are a few things you can try. So the other reason I demoed with MathML is if you are using MathType and you're converting to LaTeX and copying and pasting that, you might end up with these weird backslashes. You need to remove them. You'll see them on the editor. All right. So that's canvas for you. The next thing I'm going to talk about is sites, because that might be another place you might want to post math content. And as long as you enable the right plugins, that's also not too bad from a faculty perspective, although they do have to go into code view. So if you go to sites, there's something called the MathJax plugin. And you need to set up a few configurations. The big one you have to set up is this MathJax CDN service. You need to uncheck that. And then that Cloudflare link I mentioned earlier, it's the same link I use in the script. You need to put that in this custom MathJax location. And then once you do that, you may need to add some MathJax square brackets. So again, I think, yeah. Going to escape, I'm just going to go to the demo. And a place I've done that is here. This is a page that I've used to set up the MathJax plugin test. So there we go. So just this is the square bracket. This is a short code that works with the plugin. And we tried, this is nice because you can just put in raw MathML, and then the MathJax shortcode provides the link for you to the MathJax script library. So, and also with this, you can also put in LaTeX optionally. We don't always recommend doing that because we've had issues where it was readable on a screen reader on Internet Explorer, but not necessarily Safari. So I'm not sure how it interacts with JAWS. So the safest bet is whenever possible, put in raw MathML. It's just the best configuration. So that's what it looks like. And as you can see, you have to be in code view and your sites as opposed to your nice WYSIWYG editor. That's just the way it is. I'm going to go do the plugin setup. So if you scroll down, this is the MathJax LaTeX option. So you have to activate it if it's not already activated. The settings is what I wanted to show you. So it used to be you could just click this CDN service and it would set up the link for you. That's no longer the case. Again, you need to have this custom MathJax location. And I usually, we sometimes talk about whether you want to use HTTP or HTTPS. I just use the HTTPS, covers all the bases. And again, I have the information on accessibility.psu.edu. And this is the configuration, basically, which, again, gives you maximum coverage of MathML or LaTeX or HTML. So that is the end of this presentation formally. So are there any other questions? I know that's a lot to wade through. I'm going to try and make the slides available again and the recording available. So are there any questions? Yeah, I know. I wish it were less complicated. I think the takeaway, if you are an instructional designer working with faculty or you are faculty, is try and use the Canvas MathML, the math editor, as much as possible. If you use LaTeX, just plug your LaTeX there and you're done. If you want to do something else and you're not sure how to proceed, just contact accessibility at psu.edu and we can guide you through it. Is there anyone who has tried to use it and has run into troubles? Or is everyone just starting from scratch? Starting from scratch. Yeah, I think it's it sounds crazier than it really is. It's one of those I compare it to knitting or some other craft where or programming. Once you get into it, it starts to make sense. But trying to see it doesn't always make as much sense as it could. I'm going to stop the recording, but I will be around for a few minutes.